Hello and welcome to today's session, Bridging the Gap Between MLOps and DevOps. And today we'll be talking about how to bring the current DevOps maturity when we are operationalizing machine learning initiatives. Before we dive into the presentation, just wanted to quickly introduce myself. My name is Meeta and I am heading product at Verta, where we are building some interesting products to solve the data science challenges around ML operation and model management. And prior to Verta, I have worked in different areas in machine learning, from data annotation to actually applying machine learning in voice AI products. And really excited to talk to you all today. So here's a quick agenda. We'll talk about what is MLOps and why do we need it, current ML release challenges and what slows down ML production deployments, how to bridge MLOps and DevOps, and finally we'll wrap up. Now, ML models are on the critical path of every business today. If you talk about financial industry, there is increasing application of AI in areas like robo-advisors, anti-money laundering, and many more. There are also a lot of usage for fraud prevention, and the companies are investing heavily. We are also seeing similar trend in healthcare in variety of applications, from machine learning based disease diagnostics, image analysis, and drug research to even more advanced assistive surgery. And again, manufacturing, we're seeing an explosive growth with sensor, IoT, and robotics technology playing together. Better credit decisions are made using machine learning, and ML has a big role in building the future retail experience, from supply chain optimization, having better customer service, and even making your purchase using a robot assistant. So there's a lot happening in businesses where machine learning is helping out. So there's no wonder that companies are heavily invested in making ML work in production. And this is a trend that Gartner is seeing, that by the year 2024, 75% of the companies are planning to move their ML pilots or any initiatives in which are in R&D phase to actually operationalizing and scaling in production. But that being said, there is a reality check here. We are still struggling to make POCs and pilots and more successfully turn them into production deployment. And the success rate there is pretty low. So why is it the case, right? So if we think about the current state of ML operations, these are the areas where we are hearing again and again from different data science teams about like what is their struggle. The first area is around just having the fragmented tools and frameworks that is used in machine learning. So in ML, of course, we want to give data science teams the flexibility to use different frameworks, new technologies. They should try different ideas, which is great for innovation. But at the same time, when you have so many teams trying different tools and different frameworks, it's very difficult and hard to manage and govern them. And the next area where teams are facing another problem is just deployment timeline. So this is a quote from one of the ML infra engineer from a collaboration platform. Every time we wanted to roll out a model, we had to build a brand new prediction service and support it 24/7. So just operating and running models is sometimes one off, and it's a significant nightmare for IT teams. And the third area is just getting visibility. So this is another quote from a head of data science team from a US bank. We have half a dozen teams using half a dozen different ways of building models and as many places to run them, but we have no central place to get visibility at an organization level. So no control or visibility into for teams to know what models are running, how they are running, and who is really owning those models. Finally, this is something that we are reading day in and out, where companies roll out some AI products and they kind of fail miserably, because model monitoring is another big challenge that teams are facing, and there is no way to know a model is underperforming until we kind of the customers or the users complain. Sometimes models are black box to the team. So in essence, these are kind of some of the big challenges that we are seeing across the board. So I would say that the state of the art in ML ops is something like this. There are too many ad hoc processes. ML models are a black box to most folks. And again, this is aggravated by the fact that we use a lot of out of box models off the shelf, and one team builds and others consume without knowing the details of how the model is running or how the model is built. the release handoff process is broken, and we end up using tools that are completely misfit, that are not built for data science practices, which kind of adds to the problems. But if you look at the software world and draw parallels to it, we have a lot of focus on DevOps. DevOps essentially helps deliver software products much faster and more reliably. And again, if you look at the life cycle of software, and you have a state-of-the-art tools all across the board that work seamlessly with each other. But if you look at MLOps, we do not have a lot of mature tools at the moment. And fortunately, this is the year where we are talking a lot about operationalizing ML, and a lot of investment is going on, and a lot of teams are coming up with new processes, best practices, which we'll be talking today. Let's talk a little about what really slows down ML rollouts. The first area that I see is a big problem is just how we develop machine learning models. And model development is very empirical and ad hoc process. So data scientist starts with a simple model code, but they keep tuning it. They may be doing some hyperparameter search, maybe changing the data or features. And then finally they'll come up with a model that has the expected accuracy. And a lot of data scientists run their experiments in local environments. They may or may not track all these iterations, all these experiments. If they track it, sometimes it's very ad hoc, it's via spreadsheet. But when you think about model operations, you need to guarantee reproducibility. You want to ensure that there is proper governance. You want to go back to the exact state of the model. And to add to the complexity, model code is not enough to ensure a particular reproducibility. They start with model code, but you also need configuration, which are the hyperparameters and the other parameters that is used to tune the model. You also need environment details, so underlying libraries used, what versions of the library used, and then the data, the training data that is used to train the model. And finally, this is also equally important, where you should have the right documentation. So your stakeholders do not end up making any assumption on their own. They know all the details about the model. So everything together really makes the model much more reproducible. So this helps move you from an ad hoc model development process to much more reliable and controlled development. So again, everything boils down to how we develop machine learning, which makes it a little difficult and different from software development. But the way to manage those risks, where you are tracking all your experiments and making them reproducible. The next challenge that teams face is just the release handoff process. Typically, data scientists, as you've seen, they may be having tens and thousands of iterations, but you don't want to the entire team to get access to all those iterations, right? But you would rather share the best fit model. And again, the ad hoc process that data scientists follow to run experiments make it harder to identify which models are production ready. And then you decide to hand off the model to engineering or your ML infra teams. And this handoff process is again sometimes not elegant, and this is where things break down. And what we lack in a lot of the teams is a better transparency and collaboration between different teams, who essentially have the same goal, but they follow a very different approach. So again, the release handoff process needs to be much more streamlined. And the way this could be done is having a better model release and lifecycle management tools. And this is where a registry comes into play. And again, if I draw parallel to DevOps world, if you have like Docker registry or Artifactory, and those are kind of a similar framework that those concepts can translate into machine learning, where registry plays a very similar role, where you are putting all your models into one place, which are production ready, and have all the stakeholders collaborate in one single location. So again, having a single hub for model governance and release is really critical, and that's what we call model registry, where the data scientist teams and software engineering and operation teams can collaborate. And that helps organize the exhaust that we have from experimentation. It also brings governance and control in one place, because now folks can go and review a model, whether your security team may be able to review it, maybe if your compliance team will be able to review it and approve it. And then finally the model is released. And again, having one place where everyone can go and collaborate will essentially help enable rapid rollouts of models. And the important thing to consider here is having integration with your CI/CD pipeline and having that automation in place. And the third area is, how do you use ML to work with your current CI/CD and release process? This is another place where things sometimes break down. And when we think about machine learning models, they are built in different frameworks. Even within one team, the data scientist may be following different frameworks. Maybe they're building different models. One could be building an NLP model, one scientist could be building a computer vision model, and both models need to play together. And that adds additional complexity when it comes to just model packaging. The workflow here is really just, if you think back about, like, again, think about software and just draw a similar process into picture. You should have something in place where you're fetching model package, and running model quality tests is equally important, because you want to make sure that you have some sort of security and quality checks that are in place. So you're not releasing models without having all the avoiding any risks that is possible. And then building Docker image. Finally, you are deploying to different clusters. You will start deploying in development cluster, maybe you have a staging cluster, and then finally in production. And in each step, you may have automated tests, automated approval process, and then finally it is in production. And depending on the model type, another complexity that I want to bring up here is, maybe you're serving live inference. So your model is making predictions, like a product recommendation engine. It's recommending live, and the users are getting the prediction on the fly, versus there could be a bunch of scenarios where the model is doing a batch prediction. So maybe you're running it every hour or every week, every day, whatever is the cadence, but it's not really live. But it's a batch, but it's when it comes to batch, it's the concurrency and the amount of data that you have is super high. But again, you may be following a little bit different practices when it comes to live inference versus batch processing, but many teams would have a combination of both. So again, it's really essential that you have to make sure that ML works with your CI/CD and release process, and it fits into your software release cycle as well, because the models are not running on their own. The model API is being called by another software application. So the more tightly integrated they are to your CI/CD process, the faster you can roll them out, and there'll be lesser bottlenecks. And don't try to create more ad hoc processes for machine learning, but bring it to your DevOps process. So again, I want to bring back that point that you have to build a tooling that operates with your DevOps tools, and so that you can release models reliably. So deployment and inference serving is another key area which folks should be focusing on. And the last point is, once you have deployed in production, how do you guarantee that it is operating as expected, it is reliable, and it's giving the expected output, and it's giving a good user experience. But the challenge here is, it's hard to monitor and debug ML models in production. And that really boils down to these 4 areas. The first one is measurement. How do you measure model quality? It's sometimes really difficult, because I can go back to the example of a prediction model, right? A product recommendation prediction model. The model is giving some product recommendation to the user. There is no way to ensure that the model is giving high quality output unless the user complains, or we have the right ground truth data in place. And for the ground truth to be generated, it's a manual process, and it cannot be done immediately. It takes time, and it's costly as well. So a lot of teams struggle with ensuring that the model accuracy is of high quality in production in real time. And the second area of challenge is just customization, because each model is unique, and as so as the quality metrics. So even if you're building a monitoring tooling, you're building monitoring processes for your teams, the teams would be dealing with very different models. If you are building an NLP model, you are looking at n-grams and metrics that are way different than if you are building a image a classification model. So again, that adds to the complexity. Just the customization and the type of data that the model is dealing with can lead to the data scientist using very different charts, very different visualization, and very different types of metrics for model monitoring. The third area is, of course, pipeline chaos, because the models are relying heavily on the data. So, and the data comes from a very complicated data pipeline. You may be having an ETL process where you're cleaning up and transforming your data, and then finally it feeds to the model for training. And so there are multiple failure points when it comes to model performance in production. And just because of this chaotic environment where there's so many layers of failures and so many layers which are not visible to everyone, not having that transparency also adds to the problem where if your model fails in production, just debugging it becomes really hard. And last but not the least, the black box effect, which is very prevalent now, adds to the complexity as well, because the modeling process is complex in itself. At the same time, teams are more and more using off-the-shelf models to go to market faster, but that kind of hinders in that just the model is not interpretable for the teams, and it's a black box. So model fails, it's again very difficult for you to know why is it failing, because you do not know how it is built. So these four together makes the model monitoring in production, and more importantly, debugging and doing root cause analysis a big challenge. I would say the typical model service health monitoring, like latency, throughput, is not enough. It's important, you have to do it, but it's not enough. You have to think about the other criteria that I just mentioned. So going back to the problems and what slows down ML ops and how can we address it, the fourth area is how we monitor models in production, and having the, again, thinking through all the complexities of model monitoring and addressing them as your, depending on where your team is and what use cases they're building towards, is equally important. Now for a more comprehensive model monitoring strategy, this is what I would recommend. Start with model data and pipeline monitoring. That includes monitoring your input and output data and any intermediate results. This also includes looking at the statistical property of your model, such as drift in distribution, null values, outlier, missing data, and things like that. The second area is thinking about model performance. How do you calculate quality metrics like accuracy, F1 scores, etc.? And that also would be, it's important here to think about how do you collect ground truth and label your data. The third area is, of course, service health, which is about model latency, throughput, and resource utilization. And think about model explainability, like how do you monitor bias, how do you do cohort analysis, and finally closing the loop. It's just not about monitoring your model and getting notifications and alerts. It's also about how do you automate the next steps. That could be starting your retraining workflow or something similar, but just thinking through how do you close the loop and automate. Now to summarize everything, MLOps is in a very critical juncture right now. And when you think about an end-to-end machine learning operations in production, we have to think about these four key components. The first one is experiment management, where you are bringing the model development process and streamlining it to make sure that the model is operational in production, which involves making sure that the model is versioned correctly. You are managing the metadata of the model and making it reproducible. And then next, you are thinking about model registry, where you're creating one unified hub to manage all your model lifecycle and managing model testing, introducing CI/CD automation, and making sure that the entire team is collaborating in one single place. Then you have to think about model deployment, which involves both online inference servings as well as batch, making sure that you are deploying safely and you have the right tools to auto scale. And finally, model monitoring, which is a big beast in itself, which involves model performance, drift detection, retraining workflow, and much more. And you have to bring all these pieces together, but at the same time, think about your DevOps practices and make sure that the DevOps practices and ML ops practices are working together, and you're not building ad hoc or one-off solutions for machine learning. Thank you for your time today, and I'm happy to answer any questions that you may have.